Alright, so let's try this. We've got calcium hydroxide, has a KSP of 5 times 10 to the minus 6, and we're going to add some pure calcium hydroxide to water and allow it to come to equilibrium, and then work out the concentration of the calcium ions in the saturated solution. So, as with our other problems of this kind, our two steps are to write the equilibrium expression and to construct an equilibrium table. So our equilibrium expression, calcium hydroxide, has the formula CaOH2, and it's going to dissolve into 1 calcium ion and 2 hydroxide ions. So the KSP expression is going to be the concentration of calcium times concentration of hydroxide squared. Okay, now we'll construct an equilibrium table. So we'll have initial, change, and final. We're going to ignore the calcium hydroxide solid because it doesn't appear in the expression. We will just look at the calcium and the hydroxide. And we start off with none of either of those. So we've got none. Okay, now let's look at the equation. You can see that for every 1 mole of calcium hydroxide that dissolves, 1 mole of calcium ions is produced. So let's call the amount of calcium ions that is produced X, and we'll say that at equilibrium we've got X amount of calcium ions. Now, for every 1 mole of calcium hydroxide that dissolves, you get 2 moles of hydroxide. So if X moles of calcium are produced, then 2X moles of hydroxide must have been produced. So at equilibrium we'll have 2X of the hydroxide. Okay, we can now substitute into our KSP expression. So we know that the KSP is 5 times 10 to the minus 6. We know that the concentration of calcium ions is X. And we know that the concentration of hydroxide ions is 2X. So it's going to be 2X squared. So we simplify that out, and that gives us X times 4X squared, which is 4X cubed. And that gives us a nice, easy algebraic problem to solve. Simply 4x cubed equals 5 times 10 to the minus 6. And when you simplify that out, you should get that x equals 0.0107. And we're talking about a concentration, so it's moles per litre. Alright, so you should always refer back to your equilibrium table. So our concentration of calcium ions at equilibrium was X. So X equals 0.0107, that's fine. Part B is what is the concentration of hydroxide ions. In our equilibrium table, hydroxide at equilibrium was 2X. So we can say that the concentration of calcium ions, and we should look at significant figures. We started with 5.02 significant figures, so let's call it 0.011 molar, and our concentration of hydroxide ions will be 0.0107 times 2 to 2 sig figs, which will give 0.021 molar. And there's the problem solved.